Alright, hello everybody. This video will be an introduction to the index laws, and in an upcoming video you can practice them for yourself. So first, a quick recap. An index tells us how many times to multiply a base number by itself. So in this example, the 4 would be the base, and the 3 is sometimes referred to as an index or a power, or sometimes an exponent. Okay, and in any event, this is 4 times 4 times 4, 3 times. In other words, we're writing a list of 3 4s because 4 was the base, and this 3 up here tells us how many times to keep going. Now we have a few index laws that are basically ways to speed up the calculation process and simplify maybe more complicated expressions. So the first one is if we have a to the m times a to the n, that gives us a to the power of m plus n. So what does that mean? Well, it means when you multiply a base, you can add the powers. So if we have maybe 2 squared times 2 cubed, that is 2 to the 2 plus 3, or 2 to the 5. And if you don't believe me, well, 2 squared is 4, 2 cubed is 8, and multiply them together you get 32, and that is in fact 2 to the power of 5. We have a very similar law, which is that when you divide, you subtract the powers. And I've written as a fraction symbol here, but if you have a division sign between the two terms, it works exactly the same way. So if we keep going with this example, 32 divided by 8 is the same thing as 2 to the 5 divided by 2 cubed, which is 2 to the 5 minus 3, or 2 squared, which is of course 4. Okay, so you can see that the index laws do in fact hold up. I just would like to point out that the bases must be the same. So if you had, for example, 2 cubed times 3 to the power of 4 or something like that, you can't simplify this any further, okay, because they have a different base. So there's nothing further that we can do aside from actually evaluating what is 2 cubed, what is 3 to the 4, and then multiplying those together. But that is a lot more computationally intensive than just using these index shortcuts. The third index law relates to negative powers. So if I have a base that's raised to a negative power, I can rewrite that as a base with a positive power in the denominator of a fraction. In other words, the a to the m is going to hop down underneath. And in the same way, if I have a base raised to a negative power in the denominator, then I can rewrite that as a positive index in the numerator. And remember, it doesn't mean flip the entire fraction over, it just means bring the objects with a negative power up to the numerator or down to the denominator, but rewrite them with a positive index. Next, we'll move into something that I like to call the distributive laws. The first one is, if we have a base to a power and that whole thing is raised to another power, the outside power can come in and multiply itself with the inside power. Or a to the m, all raised to the power of n, is a to the m times n. So for example, we've got 2 squared raised to the power of 3 over here. That's the same as 2 to the 2 times 3, or 2 to the 6, which is of course 64. Next we have the power of a product. So if we have a times b raised to the power of m, this m can distribute itself over the a and over the b. And this is because we're writing AB times AB times AB m times, And because it's multiplication, I can change up the order of this. So I can write m lots of A and then m lots of B, and it should be pretty simple to see that this is A to the m times B to the m. Now if we come over here on the right hand side, we've got A plus B raised to the power of m. And I'm going to put a big cross through this equals sign because this is not the same as A to the m plus B to the m. Okay, this only works if the sign inside your brackets is a multiplication. If this was addition, the problem becomes a lot more complicated and there are different tools that we have to use. You can't just distribute the power throughout and call it done, but those tools might be for a future video. You can probably see how the distributive law would hold up for a fraction as well. The m over here just distributes itself throughout the a and the b. Finally, we have the fact that anything to the power of 0 equals 1. This is 1, this is 1, this is 1, except 0 to the power of 0. Some mathematicians would argue that it's plus and minus infinity. Other mathematicians argue that it's just 1. So for now, if you have to do a problem involving 0 to the power of 0, we just write undefined and call it a day there. So thank you all for watching this video. Again, this was just an introduction to the index laws, and in the upcoming video, you can practice using some of these laws yourself. And remember, practice makes perfect.